Well, I bet you thought we were done. Not quite. We have one further step that we like to take when it comes to predicting linear patterns. So, assuming we wanted to know how many blocks it takes to build one of the patterns way down the line, and we don't want to draw that all out because it takes forever. Well, that's why we came up with an algebraic equation that can predict any single diagram, how many blocks it would take no matter how far we look into the future. Another way that we can do that is to actually plot this graphically on a coordinate grid. All right? And the way that we're going to do this is we're going to use our table of values and to create some ordered pairs. So if I think back to the original diagram, I just have this memorized now. We had a growth rate of 2 blocks per figure, and the 0 term was 3. I just know that from looking at our table of values, which is right here. Okay, so I'm taking those exact same numbers, I'm just transferring them into this chart. Okay, but now I've added a new column, and this is where we create ordered pairs, which will be coordinates that we can plot as points. So all you do is you look at the term column, that becomes your x coordinate, and the value column becomes your y coordinates. Okay, so 0, 3, 1, and 5, 2 and 7, 3 and 9, 4 and 11, and so on and so forth. Now, a quick refresher here, if you're not completely remembering how this all works. When you have ordered pairs, they are plotting points on 2 axes. Okay, your x-axis, which is this one, it runs horizontally. So if I look at this little guide here, I just put these arrows here to show me, to remind myself, okay, x coordinates always come first, and that means you move left or right first before you do anything else. And likewise for y runs vertically, up and down. Okay, this is the y-axis. So the y coordinates tell me how far up or down I need to move. So I'm using this arrow just as a little reminder. Okay, so now I'm going to look at my coordinates and I'm going to plot those on here. So my first ordered pair is 0 and 3. So 0 on the x axis and 3 on the y axis. Good news is, when you have a 0x coordinate, it means I don't need to move left or right. Okay, I'm just going to stay at 0, and then I'm going to move up 3, which is right here. Okay, and I'm going to just make a nice dot right there. Okay, it's at 0 and 3. And I'll probably just, in brackets, mark that coordinate so I know what it is. It's going to be linear growth. So what we're hoping to see here, if we did everything right and all of our ordered pairs are correct, we should be able to draw a straight line through every point that we plot. That will be the ultimate proof that we're doing this correctly. All right? So the next ordered pair is 1, 5. So I start again at the origin point in the middle. I move over 1, and then I go up 5 to this point right here. And I'm going to mark that as 1, 5. Okay, it's looking good so far. Pattern is emerging. I can see how this could become a straight line, but I need to prove it by adding the rest of my points. So the I guess it was the second drawing, has ordered pairs of 2 and 7. So again, my x-axis, I'm going to count 2 over this time, and then up 7. So I have a third coordinate point right here, 2 and 7. It's looking good. This is a predictable pattern. You can see how a straight line is beginning to emerge. 3 and 9 is my next ordered pair. So I come down to my x-axis, count over 3, and up 9. And lastly, the ultimate test, 4 and 11. Okay, come over here to the 4 on my x-axis, and then I go up all the way up to 11 on the y-axis, and I have this right here. Okay, now I don't have a ruler on me right now, so I'm going to draw kind of a rough line, fairly straight, and I'm just going to put an arrow on the end there. And I'm also going to do the same thing on the other side. Not that it matters in this case right now, today, but it is important to know that these lines do continue essentially forever. Okay, so if we wanted to predict something, if we were dealing with time, we wanted to predict the future, we would follow the arrow in this direction. But if we wanted to work backwards and see what was happening, say with a stock in the stock market several months ago, we would work backwards and see that it has a decline, right? So meaning if something's growing, then if you worked backwards, it obviously would shrink. And that's what we've done here. So now we have done all the steps of the process, and you are on your way to becoming a master of graphing algebraic equations that represent linear patterns.